Hello, everyone. My name's Sam. So let's talk a bit about me, and then I'll tell you what I'm really here for. I'm a software engineer at Skyscanner. I've been there for about 18 months, which is not very long at all, really. So take everything I say with a pinch of salt. But if you want to get in touch, I'm on Twitter, but not worth following. Skyscanner. Who's heard of it? We're traditionally a flight meta search, very much app focused. You can get flights, hotels, car hire, more recently trains. Basically help you find your cheapest flights from anywhere to anywhere, searching many different airlines, many different travel agents, hoping to find you the best deal. Company values itself on being very sort of customer first, traveler first, we call it. So all of our kind of internal procedures and all the way we kind of operate our business is supposed to be about thinking about the traveler. What would they want? What would be best for them, even if it's not necessarily best for us. One of our most popular features, anyone who ever comes to me and is like, I've heard of Skyscanner, they always say, I like the everywhere search. You can just say, this is where I am. I don't know where I want to go. So if you've not heard of it, check it out. So what am I going to be talking about today? You've got microservices. Now what? Pain points of adopting microservices. Keeping them micro, as the name suggests, trying to not let them start out as a microservice and then scope kind of slowly grows. Reducing the repetition of work. So if you've got many teams throughout your organization and they're there focused on, this is my microservice, I'm going to build it from the ground up, and after a bit, they start going, this feature would be cool, this one would be cool, I need to have an API that does this. You're going to have multiple teams who aren't talking to each other doing the same thing. I'll tell you a bit about Skyscanner, what our kind of tech stack looks like. That's about it. I was a little bit worried this morning because I noticed myself and the other speaker had the exact same talk title. But I think I'm not quite as worried now, so it should be quite different. So it's called Scaling Microservices. This is your microservice that you want to scale. I'm not going to be talking about scaling microservices like this. There are many guides out there about how to do that. You've all heard of Kubernetes, ECS, and things like that. That's not my domain today. What I'm talking about is scaling microservices like this. So you've got another one, and another one, and another one, and so it goes on. And this is the point that I was kind of getting at before. What happens when you're keeping on adding new microservices? Where are you going to kind of encounter problems and that kind of stuff? You got the photo? Sorry, I didn't want to take it off while you were... OK, so where are we going to start? You've got your microservice, and it does exactly what you do. You're implementing some API, you're implementing your business logic, and that kind of stuff. It's all going really well. And then you realize, OK, this API, we don't want just anyone to be able to access it. And when they do access it, we want to know who it is and that kind of stuff. So we need to put in some kind of authentication to our API. Great, you've got that now. And then you notice, OK, so we've got all these different consumers accessing it. And then every Thursday afternoon, performance just drops because this one consumer is just like suddenly does a batch job and they're massively increasing the number of requests. And that's ruining the experience for everyone else because it takes some time to scale up or something. So let's put in some rate limiting. Let's say, no, right, your batch job doesn't need to happen right now. You need to slow it down and wait until we're OK. So you implement that. As time goes on, you might have other problems. If you've got to work for a company like Skyscanner, then there are constantly bots scraping your site. And this might be a problem some of your teams encounter, and they start implementing their own solutions. Cause is a big one that I've personally had to work a lot with recently, Skyscanner being across many different domains, like domains as in like web domains, makes it quite complicated. So implementing that in your microservice can get harder and harder. I'm going to kind of skip over these, but there's all sorts of different things that might be sort of common problems that lots of your teams have. And you've got to remember that it's not just you trying to fix these problems. It's probably a lot of people in your organization, if you're in the kind of hundreds or more developers kind of region, not everyone is talking to everyone. So there's definitely going to be people trying to solve the same problems. So you've got other people making their microservices, doing all the exact same stuff. So let's go back. You've got your microservice, and you've got many of them. And they're sat behind some load balancer. If you're on cloud, we use AWS very heavily, so these are sort of classic load balancers or the application load balancers. And then you've got all your other teams, or maybe even within your team, you're creating multiple load balancers. Now, maybe we could have something that sits in front of all of those and implements all of these things. And that way, your teams can stay focused on doing what they do, on their kind of specialist domain knowledge, and not have to implement every single one of these things themselves. And the solution we've found for this problem, the scale that Skyscanner is at, is an API gateway. And this sits in front of your all of your microservices and allows you to implement all of that different logic and leave your teams to solve their kind of specific problems in their microservices themselves. You can imagine this is traffic coming into your website or your service or whatever it is, and we implement all of these things here, and then every microservice is left to its own. So, a bit about Skyscanner. I'm sure you'll be happy to hear at JVM Roundabout that Java features pretty heavily at Skyscanner, along with Python and Node. And for each of those, there's kind of a main sort of supported framework. So for Java, we use Dropwizard, Python, AIO HTTP, and Node use Express. And the idea of this is to try and, if we try and keep all of our microservices looking a very similar shape, then we keep the problems that people are encountering similar, and then it makes it easier to solve those kind of at scale. So we're not trying to solve them in many different ways. In terms of platform, I mentioned before we're on AWS. Traditionally, we've been almost completely on Amazon's ECS service, which is essentially just distributed Docker. It allows you to run Docker across many EC2 hosts, and then more recently to Kubernetes, not through EKS. We're sort of running our own Kubernetes effectively. In terms of our sort of continuous integration and continuous delivery, this is something that's pretty important to Skyscanner. So shipping fast, failing fast, shipping multiple times a day is kind of a thing that's definitely celebrated, especially more and more recently. We use Drone, which is an open source sort of continuous integration tool, similar to something like Jenkins, but it's a bit, it's not nearly as popular, but it's based on a very sort of simple concept of every sort of step in your pipeline is just a Docker image, and that Docker image has an entry point, which could be anything. So it could be a bash script, or it could be your unit tests or something, and this allows you, each part is sort of very sort of plug and play. You can sort of publish these plugins, which are essentially just Docker images to some sort of registry, and your pipeline is just sort of essentially a list of Docker plugins that or Docker images that you run. And then we have our own in-house deployment tool called Slingshot. Now this has existed for a while at Skyscanner, and it started out just basically doing very simple microservice deployments. More recently, it does things like deploy infrastructure using CloudFormation, just by essentially applying your templates with parameters that you specify, and deploying things like Lambdas. And this allows you to have quite a complex deployment pipeline to get your microservices sort of out there as quickly as possible. And Slingshot, there's a sort of pretty much an entire team dedicated towards developing that, because the way the organization sees it is that it's very essential that you need the right tools for your developers to be able to deploy their microservices quickly, detect problems quickly, and have that sort of fast sort of iteration, those sort of fast iterations, in order to deliver value to your customers quickly. So I'm going to pop back to API gateways. We use an open source tool called Kong, which I'm sure quite a few of you might have heard of. It's essentially a wrapper around Nginx that provides an API to update its configuration to allow you to sort of update that dynamically rather than having to sort of edit a config file. So we use Amazon EC2 for this. This is my EC2. I was actually a bit surprised making this. All the icons seem to have changed recently. I wasn't something I was aware of. So this is Kong. This is the logo, little gorilla running on that. And then the other main thing we run on there is Hacker, which is an open source project from Mozilla that basically just gets your logs off your image, off your box, basically. Of course, it's not just one of these. Our API gateways are serving in the region of 500,000 requests a minute. So we're running, it's a reasonably large scale across multiple AWS regions. So they've got sort of multiple clusters of these sitting behind load balancers. This just show load balancers also provide us some metrics that help us with diagnosing any issues. And all the Kong configuration is stored in an RDS database. So, and the last thing here is I mentioned rate limiting before, to give a kind of consistent view for each node about how many requests each consumer's made and that kind of stuff. We use Elasticache, but I'll kind of keep going. And then this is just to show any requests coming in. Kong does kind of path-based routing to say, which microservice should I be sending this to? Got your phone? So I'm sure, as you can imagine, there's a reasonable amount of complexity already, and this goes wrong a fair bit. And I mentioned also that, well, a fair bit. It can go wrong, and you have to sort of plan for this eventuality. We have this kind of multiple AWS regions, and the idea is that we can kind of progressively allow our engineers to deploy changes as of when they need to using Slingshot, our deployment tool, and that means they can kind of deliver value to our customers. It also means they can break things whenever we don't know they're going to do it. So we need a pretty resilient global routing strategy. We use Akamai as our CDN. I don't know if you've heard of it, but it's a reasonably large one. And essentially, if you go to any sort of Skyscanner domain, we direct you to some region. First of all, we decide, are you near kind of Europe or are you near Asia? And then, say you're near Asia, we send you to kind of like our APAC only domain. This is essentially just like we're CNAMing you to another domain. And then from there, we kind of 50-50 weights all the traffic between two regions. We do the exact same thing in Europe. But the idea is that we use the kind of Route 53 health check. So any time if we detect there's problems going on, say engineers completely messed it up, both of these regions here are broken, we can just redirect all the traffic straight over to Asia. Now, that might not be great for performance, but it means that any time we're kind of we can serve the traveler. It's much better to be online and slow than completely offline. From these kind of failover, this sort of apex domain, so we have health checks saying, if this is unhealthy, send the traffic here. We can do some further health checks to say, where should we send the traffic to? So that's how we kind of do the crisscross. Now that allows us to test, say, a whole region's having a problem, or maybe even a whole hemisphere. But what happens if just an individual service is having a problem? We might not want to completely take that region out of the picture. So I mentioned before we have Kong, and it's essentially Nginx, like a sort of reverse proxy. A request comes in to region A, and it wants to access some service foo, so we send that to foo. Another request comes in to bar, and that request goes there. But say we've noticed, that service is having issues right now. Someone's gone and deployed some code, and it's completely broken, and it's not going to be fixed in the next 30 seconds. So it's going to be a matter of minutes. We need to, a request has come in, we need to send it somewhere. We can kind of dynamically send that request to another region. I talked about that Kong API before, and that allows us to dynamically say, hey, any request coming in for this service, you can't send it here. It's completely broken. I need you to send it to this other region. Yes, there'll be some performance problems, but like we need to serve that request. So having something as flexible as Kong, it's a really solid sort of open source project that we're able to build upon. We're able to serve requests hopefully all the time, if not whenever we can. And obviously, every service, we try to make sure it's deployed in all 4 regions if possible, just to be sure that we can maximize the chances of serving that request at any time. So deployments, who has heard of, or uses blue-green deployments? A few of you. So the idea here is that you have your instances running. These can be containers or virtual machines or whatever, and you want to make a change. So instead of trying to make the change to these live running boxes, you sort of bring up new ones and let them serve some of the traffic. So this essentially means you're very over-provisioned for a short period of time. If things are looking bad, it's very easy and very quick just to get rid of those new instances. And if things are looking good, after a period of time where you're like, okay, things are looking happy, you get rid of the old ones. Being fully in cloud, like Skyscanner, means you can be very flexible. You're paying by the minute for these instances. So being doubly over-provisioned twice, for like 3 or 4 minutes, it's not that big a deal cost-wise. But what about something more disruptive? Say you need to make a change to your whole stack. I talked about this before. This is our gateway setup, but this could be anything, right? Like you've got some microservice deployed. They're talking to databases. They're talking to all these different things. Well, why not do the same thing, but for your entire infrastructure? So one of the great things that Slingshot allows us to do is redeploy a whole second copy of our infrastructure. And the only thing you kind of really need to do is to be able to replicate your data stores. If you're using some caching, then probably that doesn't need to be replicated. But I'll talk a bit more about how in this specific case, we're able to kind of replicate our databases quite quickly. And yeah, like I mentioned, Slingshot is the tool we kind of use to do this. And this gives you complete isolation, right? Because you've got your 2 load balancers. They both have some DNS records, and you can use Route 53 has this kind of weighted endpoints, and that means when someone does a DNS lookup for your service, you can say, I want 99% of the time, give them this one. This is the one I know is good, it works. But 1% of the time, give them this one. And that means you can start to slowly move traffic over dynamically and say, continue to monitor your metrics, continue to do those checks. And this can be, to begin with, if you're implementing this, just do it manually, right? Like move 10% of the traffic, look at your dashboards, is this looking good? And then slowly over time, you'll build up that confidence to be able to do this kind of more automated. I can start out just being like a script you run locally, checking some high-level metrics, and you kind of keep an eye on it. And as things progress, you're able to automate that more and more to the point where you can do kind of complete infrastructure deployments, move that traffic over, monitor the metrics the whole time, and get rid of the old one, and be having your lunch at the same time. And if you come back, all your traffic will be on the new one or the old one, depending on how it went. But how to keep them in sync? So this is not going to work for every service, but I'm just going to describe how we kind of keep that gateway configuration in sync. So when engineers define their APIs, so they're setting up a new one, they say, essentially, this is kind of going to give you a bit of insight into how you kind of specify what they call a drone plugin, which is essentially a Docker image that you can see there. We've got a specific one. It just looks like a normal Docker image. You're allowed to sort of pass it some parameters. So publish as, we essentially mean what's the name of this API. So if you go to sort of skyscanner.net/myAPI, where should we send that? You can provide some basic parameters. So these kind of, you'll see these kind of correlate with things I talked about at the start. Things like IP restriction, rate limiting, bot blocking, health checking, and all that kind of stuff. Like how should we know when your API is healthy? What kind of response should we expect? Which endpoint should we be checking? The great thing here is that engineers are able to define that in their Git repositories. They're completely in control of that. But we want to take that configuration and update the Kong configuration, which is stored in Postgres. And we need to give developers control of that and allow them to release on their own cycle and not stand in their way. But at the same time, we need to kind of make this happen in a kind of seamless way without us get involved. So, like I said, we need to talk to the Kong API and store it in Postgres. Now, and that information needs to come from GitHub. We trigger a drone build when engineers deploy to, like, sort of merge to master. And because at Skyscanner we have this concept of kind of a merge to master is a release to production. So what we could do here is have drone just talk to these Kong instances, and this is actually what we used to do. The problem with this we found was that at any given point, it's really hard to know what should be running in production. Like, yay, okay, we triggered some config changes, but like they used to have the master branch as their like default branch, and now they've changed it. So which one do they build off? Or maybe they have like a special branch they use for releasing, like that's all up to them. So it's really hard to kind of, you'd be sort of searching through Git going like, don't really understand, like this is the state this API is in, but I don't really know what did the developer intend. Maybe that kind of stuff is fine at the start, and it's probably the right decision to do at the beginning as we kind of worked out how people were going to use these APIs. But as time went on, it got more and more to the point where we were kind of manually tracking people down and saying, hey, like, do you even use this API anymore? And it got a bit manual. So what we kind of thought was we need some source of truth that sits in a place where we can say, right, if we ever need to recreate this config or need to know what should be happening, that's where we look. So simple thing, we just made our drone builds, copy everyone's config to an S3 bucket. And we use the kind of S3 built-in inversioning, so each time they upload a new one, it just kind of overwrites, but really behind the scenes, all the old ones are still there, so if we ever need to revert or anything like that, we're good to do so. And what we do is trigger notifications on that to kind of, and we have this service called Kong Loader that kind of consumes off a queue to update that. And from Kong Loader then sort of talks to the API. Now that means that whenever we're deploying a new stack, all our configuration is here. So we're able to kind of completely recreate that from scratch if we need to. As I mentioned, we're in multiple regions, so we don't actually have just one S3 bucket. We store that across all four regions. The idea being that every region is isolated, and any problems in one aren't going to affect the others. I think I've gone a bit over my time. I'm not sure, but we're hiring. Are there any questions?